Doug, you have muted yourself. It says guest has muted themselves. In eCam, I think.
Can you send him a...
Well, Paul, good to be talking to you.
Good talking to you, too.
And welcome, everybody. It's Science Friday on the Common Good Podcast. Doug's going to figure out his microphone. We're still new to this, 2 years in, and we're still figuring things out. But we're excited to have Paul Wallace on the show, our resident astrophysicist, pastor, and birder. And we're going to talk about science and light waves and the big crunch, the end of the universe as we know it. And we've got a big show ready for you. Doug, you with us?
Am I back?
Oh, yeah. You're creeping and you're quiet, but
I don't know what's happening. I don't know why any of this is going on.
We spent 10 minutes talking with no problem before.
Yeah, that's right. I was going to say, boy, we got the countdown timer working and all of it was there. And all right. Well, thanks for covering that. I had to beam out and beam back in. And I'll tell you, Paul, that's a Star Trek reference that there's just an awful lot of times with all these Zoom calls that some of us who grew up watching that little science fiction television show.
Yep, the original.
Feel like there's this, beaming up and beaming down sort of business. Hey, we talked about the weather yet? Because it's we got a winter in Minneapolis today. It's glorious. I mean, for all the prayerful complaining I've been doing for all of the spring, the last few days, the next few days, are going to be glorious. How's it looking there, just outside of Decatur,
Atlanta,
Georgia?
Yeah, well, outside the window here in Decatur, that is basically Atlanta. It's really dark, really cloudy, and we're going to get hammered with some good lightning bolts here pretty soon. Wow. So if I go dark, I'm probably all right. Just,
And Dan, how about there in South Bend? How are things looking?
Similar. It's dark and drizzly and cold.
All right. Well, Minneapolis for the win today. That doesn't happen very often, that the weather win goes to the kids from the...
So what do you have, like 60s and 70s clear?
Yeah, exactly. Yes. And it's happening, on Mother's Day weekend, and just going to make things better. Because around here, any chance you have to have the weather not hurt you is just a real sense that maybe life is gonna go your way. Hey, Paul, speaking of things might go dark there.
Yep. You're
looking a little more lit today, and that's not a casual reference of a hip kid. Yep, literally, you look more lit.
I do look more lit. Do you know why? Because this guy, somebody sent me a ring light. Yeah, I had to hook up to my monitor here. So I've got, I have a light in my face now, whereas before all I had was like fluorescent lights behind me, and you cannot see my... Well,
show us the difference, because I think in our conversation about science and lights and light waves.
So this is with lamp, and this is without.
Used to be
world of a difference.
And
before,
let there be light,
and after,
and now there's light.
It. Yep.
Okay, and so
I don't know who sent it to me, but it was really nice.
I did. Don't miss out on the opportunity to take a little credit. I mean, why do a good thing if you don't get credit? That's what my mom always said. What's the point? And my dad said, I was basketball player.
I think Jesus said that too, didn't he? He said when you pray, go out on the street corner so everybody can see you.
They see your good deeds. And
when you give money, make sure you make a big show of it. Stuff like that.
Yeah, you don't want to make a big show of it. You just want to raise your hand and take credit.
Just make sure they know.
Just let the truth set you free. Is that I agree. Hey, but the reason, is because the human eye can only take in so much light, right? So when things are more lit, and our cameras are kind of like a human eye, and they can only take in so much.
Yep.
They need more saturation of light. And this is a thing. We've been talking about these light waves on here, this light wave theory, that light moves as a wave.
This theory, yeah.
And so I don't know if you know what I'm about to get into here, but the different light tones is something that is like all three of our images here not only have different levels of brightness because of what we have going on in our rooms and all that, but they have a different tone to them, right? Or you can get colored lights that are changing. And I got to tell you, I've thought a lot about, you know, light stuff as we've talked here and in other places because it's interesting. I don't really understand the hue business. Do you understand that? Or is that just like, I don't know, it's kind of cameras and...
Well, I mean,
you know, you go to buy light bulbs, like you go to buy light bulbs and it's like, do you want the summer light bulb? Do you want the bright white? Do you want the reveal? Do you want the more, you know, amber colored ones? How does that happen? Is that just something with the optics of our eyes, or are the light waves different? Do you know?
The light waves are different. Basically, all of, you know, imagine there's pure white light, which has equal representations of all colors, right? The only thing that makes any of those different is that they might have, you know, are different deviations from white. So, you know, it might, you know, like the light I've got here has got a little more tilted towards the red. So it's got a little bit more longer wavelengths in it than white light does. There's just a little bit stronger in the long wavelength part of the light. A bluer light, see, I can make my light now. I can make it look blue. I go the other way, like this. So now blue, that's got more short wavelengths in it. So the light itself is quantitatively different. There's my red again.
I don't understand it. Okay.
Anyway, it is the light.
So pure white light is all of the light wavelengths, and then when you change it to more of a hue, or if I change my, you know, my little background to kind of red here because I got you know, fancy little lights, it's taking away some of the light waves. Is that what's happening?
I don't know. It could be. You would get the same effect if you would get the same color effect if you removed blue light from it, or if you added red light to it. That is, if you removed short wavelengths from it and added long wavelengths.
And color is just the wavelengths. Yeah,
that's it. Yep. Short wavelengths are purple and long wavelengths are red, and all the other ones stretch out between those two. So by short, so short is about 400 nanometers, which is about 4/10 of a millionth. Yeah, 4/10 of a millionth of a meter. So it's very short, you know.
Well,
and then long wavelengths are roughly twice that long.
I mean, I shouldn't slip into the philosophy when setting up rooms and lights and trying to get our video stuff right, but it just feels like you're dabbling. I mean, like, okay, I know I can make changes that have a certain look to them, and I know what that is. You start thinking a little bit about it.
Yeah.
And it's like, huh. Is this just a human invention? I mean, before human beings had a light bulb.
Yeah.
I guess fire was giving off a different light wave.
Right. Right. And then sunsets, you know, you get that nice red, orange vibe.
So how does that happen? What is that?
The atmosphere, when sunlight passes, when any light passes through the atmosphere, let's say white light, the light from the sun is approximately white when it hits the atmosphere. But when light travels through the atmosphere, blue light gets removed from it. So the more atmosphere the light goes through, the redder the light gets because the more blue has been removed from it.
I see.
And when you see the sun at sunset, you're looking through a very thick layer of atmosphere at the sun. 2, 3, 4, 5, 6 times thicker than when the sun's over your head.
And so some of the atmosphere is blocking some of those light waves because the nature of their length.
Yeah, it removes the short wavelength stuff, the blue light from it.
Why does it do that? Why do the short wavelengths not make it through the atmosphere? Because
the molecules in the atmosphere vibrate. They have all kinds of frequencies at which they vibrate, and those tend to cluster around the blue end of the spectrum. So red light passes right through them, but blue light, they resonate with the blue light and rescatter it back out.
So the light wave hits these molecules that are vibrating at their same wavelength, and they get all caught up there, and they
exactly, and then they re-emit them, and they re-emit them in different directions, which is known as scattering, which is why the sky looks blue. That's all the blue light that gets removed from the sun. All the sky that you see that's blue is all light from the sun, but it's light that's been removed from the beam, sort of the direct beam of the sun, and scattered out in different directions.
Well, that's son of a gun. There we go. Boy, I mean, if you've laid on the ground and looked up and thought, why is the sky blue? And I've always just, here's what I thought it was. That around the ocean, no, that's why the ocean water looks blue. That it's reflecting the sky. And that the sky was just the atmosphere. So I didn't really know what that meant. Like that, it's the atmosphere that's making the sky look blue. You're saying it's taking the blue waves get scattered by the molecules in the atmosphere.
And get scattered randomly about in the atmosphere. Yeah. But the red light just keeps on moving. That's why when you look more directly at the sun, it looks redder. Because all that blue light's been removed from that.
So when Jesus comes under the blood red sky, how is that gonna happen? What are those light waves?
Yeah, that's beyond what scientists can.
You got to put on your pastor theologian hat for that.
I think when that happens, all the physics rules get suspended.
So Paul, I pulled up this Kelvin color temperature scale.
Oh, cool, yeah, nice.
Now we got like 10K is blue sky and down to 1K, which is like below the color of a candle. What's the K? Is that the wavelength they're describing, or?
Imagine that you've got like, your little electric eye of your stove, your little, what do you call it? Like a heating element,
Mm-hmm.
Like when you heat those up, they're red, right?
Mm-hmm.
That means they're down there around the 1000 to 2000 K. That's Kelvin, right? So you can see how it's kind of red down there, reddish orange around 1 and 2K. That's how hot the eye of your heating element is.
Okay.
And if you can make it hotter and hotter and hotter, it would start to look yellow and then blue. So if you could make that heating element 10,000 kelvins, it would look the same color as the sky.
Gotcha. Wow.
But it would be super bright. It'd probably blind you at the same time, but that's what color it would be.
Okay, so this Kelvin.
Hot things are blue and cool things are red.
Okay, so there we go. There's a mental shift from what a lot of people say, because you think red hot and cool blue.
Exactly.
And you're saying
I'm saying that
mind-opening
objects like, for example, stars, cool stars are red. Deep in the deeper red they are, the cooler they are, and very hot stars are blue. They're literally blue.
Wow. Yeah, because I've always thought as white as the hottest, like white hot.
Right. But no, it actually.
But you can get hotter, you can get blue.
When things get hot enough, they get blue, and eventually they would even look a little purple. It's true. No, and it is opposite. Like the little.
It's true. He has to say, because the dead silence convinces people.
And like the.
If
little,
you say so, Paul.
Yeah, I'm just making this up. I don't know anything. Like the little knobs on your sink, right? The blue is. The blue means cold and the red means hot, but that's
that's the rule of hot and cold things.
No, that's exactly right. Yeah. So that's all this is telling you. That's all that scale is telling you.
Wow.
Okay, so let's talk about Kelvin for a minute. That's a person, right?
And Lord Kelvin. Yep.
Lord Kelvin. And Kelvin was Fahrenheit also a person, or was that another phrase? Yeah, these truly are the last names.
Kelvin was a better person.
So these are the names of two people who I don't know what period are we talking here? 1700s.
Kelvin was mid 19th century, mid late 19th century, and so Fahrenheit I try to not think about.
Really?
Not because I'm just joking. Not because of him personally, but because the scale was so wretched that I.
Yeah, it's like thinking of inch. You don't want to talk about inch. You want to talk
about it's like the English system of units that we use. I don't like to think about it. I like to think about the metric system.
Yeah.
So many things in science are linked to the person who brought them to the forefront. Maybe they discovered them or became the most populist person around them. And the idea that Fahrenheit, temperature measurement is named after a person who discovered who coined that
invented this scale. Yeah.
And then Kelvin is also a person. Just sort of reminds us that science is people business, right?
Yeah,
I mean, that people are in it and they're discovering it and they're competing with each other. And I read some science history books about this kind of stuff, and it's all the human drama you can imagine. I mean, a lot of people don't know that scientists are also interesting human beings and not just lab coat wearing robots with flesh on them.
Right.
That there's all kinds of interesting stuff going on. So what was Kelvin? Did he discover this business, or did everyone sort of know that this is how heat and light waves and so on worked?
No, he didn't discover that business. He was just looking to set a temperature scale that made sense and was based in something based in something real, that was founded on a real absolute limit and not just what is interesting to people. Like, for example, the Celsius scale, right? It's based on the freezing point and boiling point of water. And that makes total sense, right? I mean, because water is so important to us. But Kelvin set his zero at an absolute, at a fundamental absolute physical limit of absolute zero. Still put 100 units between freezing and boiling of water. Okay, so a change of 1 Kelvin is the same as 1 degree Celsius, change of 1 degree Celsius. But but point is that his is the Kelvin scale is based on something absolute, an absolute limit, which is absolute zero. A temperature, by the way, that we can get arbitrarily close to is kind of like the speed of light. You can get arbitrarily close to it, but you can never reach it.
Huh. It's a Jesus Jones song that sounds like that. You can look, but don't touch. You can drink, don't swallow. So Kelvin was working on temperature.
Yes.
For some variety of important reasons.
Yeah, he was interested in it.
This is now translated to most people's lived experience into light wave and tone colors. So I have a light in front of me right now that has a percentage thing on it of how bright it is. And then it says 2600 K, which is 2600 Kelvin. Or if you go to your store where you buy light bulbs, it's going to list the color. You have to like translate brightness and color. So it moved from temperature to light wave hue. Back to this question.
Yeah, right. And it's just because, and it's simply based on the fact that an object, if you have any object at say 9,000 kelvins, it's going to look that color. Doesn't matter what the object is, whether it's a star, whether it's the heating element on your stove, whatever it is. Molten lava, doesn't matter. If you have any object at 9,000 kelvins, it's going to be that temp. It's going to be that color. So it's just a simple way of categorizing hue. That's all it is.
So
it doesn't mean that your light bulb was actually 9,000 kelvins, because it's not.
It's not running hotter per se.
No, it's not really that temperature. It just looks the same color as an object at that temperature.
Wow, so Jim Eaton in the chat says, like the blue flame on your gas stove. Is that accurate, or is it's just the color? It appears to be that color, but it's not actually that hot, right?
Right. I don't think that is a particular chemical reaction that's happening there, and I don't think that's the same thing as simply heating an object up to that temperature.
Huh. Jeez, I saw his comment and thought, well, now that makes sense when I saw it in the chat. And then you're like, no, that doesn't make sense. So I was with you there, Jim, for a minute. All right. See, I just find light waves so fascinating that they're moving at the same speed, but they have different lengths. It's just such a mental, I don't know, like it's just hard to wrap my brain around and believe that that light, well, first of all, that light is both particle and wave at the same time. So, I mean, now we're deep into the Einsteinian question. Is that true? Am I right about that?
Yes, you're right about that.
Okay. And then, that now you get different wavelengths, but the speed's not changing at all.
It's not changing. Right. It's like having two different trains going by you, one with short boxcars and one with long boxcars. They're both going the same speed, but the one with the short boxcars, you're getting more boxcars per second going by.
Yeah, maybe that's helpful to think of it as waves per second.
Yeah, frequency.
Frequency.
Yeah. The thing that makes light, what your eye interprets is really not wavelength but frequency. That's really and for light waves traveling around in space in your room there and around the Earth's atmosphere, there's a 1-to-1 correspondence between the wavelength and frequency. But what your eye really responds to is frequency. And so you can see how the train with short boxcars, you'll get more boxcars per second, even if they're both traveling the same speed.
So I'm going to speed up the light waves behind me in my little setup, and we're going to get.
Not speeding them up. You're just making them shorter. You're gonna increase the frequency.
I'm going to speed increase. Would that be different than speed up the frequency, or is that fair?
Yeah,
the same thing?
Speed up to me it sort of connotes like speed through space. Yeah. And they're not going any faster. They're just more wavelengths per second.
Well, after 20 minutes of talking about this, your light looks great. So
thanks, man.
Yeah. So congratulations on the great looking light wave. All right. Hey, a couple other things in the news, Paul. The people on the International Space Station, cosmonauts, Russian cosmonauts, as well as people from the United States.
Yeah, they're getting along up there, aren't they?
Yeah, right. That's right. And they were shot up there by SpaceX. So Elon Musk brings the world together in a way that, the rest can. You think Elon Musk has anything to do with the operation of SpaceX at this point? Like, is he noodling around in that thing too? Or does he
I find it hard to believe. I mean, I imagine, how much can one guy do? Seriously. I don't know.
I bet he gets in there and helps design like the uniforms and stuff because they're very bad and they look like he had a hand in it.
Are they ugly uniforms? SpaceX uniforms?
I think so.
That's good. That's a good point. I don't know what the uniforms look like, but this is kind of cool, right? That both the international flavor of this, that people from 3 different nations are on the space station, they're living together. I did hear on a report yesterday about the fact that new people are going up to the space station for 4 months, and some people have been there maybe for 6 months or coming home.
Yeah, right.
Or coming back to Earth. That the cosmonauts and the U.S. astronauts live on different sides of the space station. In different quarters. Yeah. Like, there's a beauty of they've all come together. We've now worked together, 2 nations and private industry to put all this together. It's an interesting model of exploring space. I know what you think about the particular characters and players and all this. But then when they get up there to the International Space Station,
go to their separate rooms.
Yeah, they go to their own sides.
Well,
sometimes up here.
Maybe that makes life better. Before we moved into the house that we're living in now, my wife and I, we fantasized about having our bedroom on one side of the house and all 3 kids' bedrooms on the extreme other end of the house.
Yes.
And it turns out that's exactly what the house that we ended up getting was, that actually came our way, was exactly like that. And it makes life possible. It makes life, it makes living together possible. So maybe it's kind of like that. It's like, they love each other, but you know what? A little distance.
Need some space.
Just a little space can be healthy.
But you don't need space from everybody. It's not like you need a little alone time. You just need space from the astronauts, or you just need a little separation from the cosmonauts. I was struck by that. Like, sure, we're going to share the International Space Station, but and then you just wonder, are they absolutely equal in their accoutrements? Or is one of them? And what do they do up there? Do you know anything about? I get it that they're doing science things.
What are they even doing?
That's a good question. I don't know what they're doing, but I think a lot of it has to do with they themselves and how their bodies respond to zero gravity over long periods of time. That's a point of great interest to a lot of people. And also about how plants do things like plants and so forth and do in zero gravity. Can plants even grow in zero gravity? Who knows? Well, we know now, probably.
Yeah, I think I saw this mission that just came back. One of the things they were doing was growing chilies in space.
Mm-hmm.
So, see how the chilies did.
So basically, it's just a laboratory for long-term experiments in low gravity. Basically, think of it that way. Zero gravity, really, effectively.
Yeah. Well, I pulled up a picture of the astronauts' new suits, the SpaceX suits.
Those are them right there?
That's them right there. They're just sort of like, if you remember the classic NASA suits.
Those kick butt.
Yeah.
Those are awesome.
Very cool. But
Remember
these just look like cheap Halloween costumes. I don't know.
Yeah. Right.
What was that? What was that came out a few years ago? It was like the raw footage from the Apollo 11. Remember that? That it was like 3 or 4 years ago. Yeah, it was so beautifully done, and the spacesuits were so killer.
Mm-hmm.
Yeah,
they were so awesome.
Yeah. So I get it that they're doing experiments, but you can only work so many hours a day. Do you know anything about like how these people spend their time up there?
No.
You can't really go outside. You only go outside for work. I mean, it has to feel a bit imprisoned.
Well, I think that's another part of the experiment is to see how people psychologically deal with this sort of situation. I mean, this is all unknown, really. You know, I think there was a fellow who had been up there for a whole year, and he'd been in space longer. This was none of these folks here, but I remember reading a while back about some guy who had been there for maybe a bit over a year.
Mark Kelly or his twin brother, because one of the twins stayed on Earth and one spent a year in space. Yeah.
And so, you know, that's part of the experiment too, is the psychological, you know, how people can handle this.
Right.
You know, and can they handle it without cracking? Even healthy people, you know, really healthy minded people, can they do it without just killing each other?
Yeah.
And I think I've read that they have to exercise like multiple hours a day.
So
on a treadmill, so they're simulating some sort of gravity on their bones
their
and muscles.
Won't atrophy. Yeah.
Do they wear those helmets all the time? Like, are those oxygen helmets, or they just have those on just to look?
They don't look like it.
I think this picture is them either just arriving or just getting ready to depart. So that's
they don't wear that.
Yeah.
But they just, what do they wear up there when they're just sitting around? Like they throw their sweats on in the afternoon and just kind of
t-shirts and sweatpants, probably.
Yeah. Truly, just wearing t-shirts and sweatpants.
Yeah, probably. Whatever's comfortable. I mean, you need to reduce the number of annoyances you have when you're up there. I think putting on comfortable clothes is probably a good idea.
And I guess they've come back now, right? Wasn't the splashdown supposed to happen?
Like
it's 8:42 Central Time. Yeah, so middle of the night they came splashing back in.
Yep. Apparently they made it.
Yeah, this is apparently an image from that. You got the 4 parachutes and the infrared image of the capsule.
Oh, it's infrared. That's why it looks so weird. Of course, because it was nighttime. They needed to take an infrared picture.
Still, absolutely so cool, right? That cool. We're shooting people up in machines to, orbiting space stations. They're living up there, and then they're getting in another capsule that comes back down here and lands, and then they reuse it and pack it all up and send it back up there again.
Yeah, that thing's been up there for 20 years now.
Yeah. Well, that's the other thing is that 20 years ago, they were pulling this stuff off. You just take technology back 20 years and think about all the things we didn't have, in 2002,
it's interesting too, though. Like, we've progressed a long way, but we're also just sending people up in these little capsules on top of rockets like we did in the 60s. Like, it's sort of interesting we haven't progressed past that very dangerous sitting on top of an explosive device.
Well, it's one of those things that is just like, there's just no design. Improving on that design is just virtually impossible. It's like the basic design of a car hasn't changed in 100 years.
Yeah.
It's just, or more.
Mm-hmm.
It's just, really nothing else to do.
I saw a little internet funny meme thing the other day that said that if you look into the George Jetson biography from the cartoon character, the age that he is in the cartoon and the year that the cartoon is supposedly set, he was born in 2022. He was born this year.
Oh.
Yeah. So we are now I think he's 42 years old, because I think it's 2064 or whatever.
So we're looking at my kids, like, being in Jetson world. They'll be a little older than George. They'll be older than George, but they'll be there.
Yeah. When they're your age, that's where things are supposed to be. And turns out that's probably not going to be that way, but we're going to have really great video doorbells and some of the rest of it,
sort of like Back to the Future, when they go to the future and it's like
totally
we're not even close. We don't have hoverboards. We don't got nothing.
Yeah,
nothing. All right. Hey, a couple other interesting news flashes that came across. And, every week when we start gathering up the conversation points here, it just feels like sometimes it gets wilder and wilder about what pops up in the news. And we've talked about this a lot, the role of science in our society, how important it is, and how much people on all sides of opinions and political perspectives and worldviews use and don't use science, right? So this week, a lot of news about the Supreme Court changing the Roe versus Wade standard for rights for women in the United States to terminate a pregnancy. And one of the arguments from people who want to see that right diminished or changed or taken is they're arguing science. They're saying we know more about the development of fetuses and all this stuff. It's a science argument. And why do all use science? People not want it. And of course, pandemics and masks are about science, and all the social science about school. And like, it's mixed in our society all the time and has all this great implication. And then there's like the hard sciences, sometimes some of us refer to it as the real sciences, stuff like you do, or experiments. And there's theoretical science.
Yeah.
And all of this is mixed together in this big pot of gumbo that we call science in America, right? Just like grab all of it and throw it in there, and throw in a little social science, throw in a little biology, throw in a little chemistry, throw some speculative science in there, and so you end up with these headlines that work, right? I click on things like that scientists say there's an antiverse running backward in time. Because
I gotta check that out.
Right?
Yeah. Like, well, there we go. That finally explains it, because the universe made all the sense to me. So now I'm just going to assume that there's an anti-universe.
That's right.
And that's where all the black matter goes, or whatever it is.
Yeah, this could literally also be the plot of a Marvel movie. Like,
right. Yeah.
The anti-universe running backward in time. It sounds like Doctor Strange stuff.
Yeah. So obviously, people in the astrophysics world, your world of training and teaching, they're always exploring ideas, right? That's what they're supposed to do, and they do, and it really helps. And most all of the things that become real in our world that involve physics have some sort of speculative nature to them at some point. Someone said, I don't think that's how that actually is gonna work. Yeah. So there's important pieces to all this, but it does strike a human being's mind a little funny, doesn't it?
Yeah, it does. And it's also like it says, there's all kinds of things to talk about here with this headline. But the first thing that I thought of was, it's really difficult to justify, when you're trying to explain to somebody how science works and how you really should believe scientists when they say things like wear masks and get vaccinated. And then scientists say get vaccinated. And then you see scientists say there's an anti-universe running backward in time. And it makes you think, are these the same scientists? And, it does sort of throw a wrench into, those who are saying, please listen to what scientists are saying. To those who don't know that these are completely separate scientists living in completely separate worlds, doing completely separate work,
Is that true? They're just totally of a different space or a different engagement.
Yeah, I mean, well, yeah, in a sense, from public health science, yes.
Oh,
Totally.
I see.
Yeah, and they're, what they're doing is they're taking theories of the universe that we think we have pretty good reason for thinking that they're right, and they're sort of just taking these basic theories and trying to build on them and track down consequences of them. And a lot of it's theoretical. They're sitting at computers, they're sitting doing math on a whiteboard. I mean, it's a totally different, world that they're living in.
Yeah,
and it's a good thing they're doing, but I think what I'm trying to say is that people don't realize how big and variegated science is.
Yes.
Yeah, it seems like you've got the people in the lab, and then stuff like from this headline seems more like a couple of people late at night around a campfire, like, whoa, what if there's a backwards universe?
Do you know, in the astrophysics world, are these people being referred to as anti-universalists? Like they're like anti-vaxxers? Are there people that are like,
right.
Hey, I'm not sitting at the table with the anti-universe people. It's just there is a universe, and I'm not going to be with the anti-universe. I don't even know what this means. Do either of you recognize these words? And then
my guess is something like this, and there's a history of fruitfulness to this kind of thinking. Basically, what I'm imagining is doing is they're looking at some equations that some general relativity equations, maybe some string theory stuff, and I don't know. I'm just guessing. And they're looking at maybe one of these proposed models for string theory, say.
Okay.
And they're saying, well, if this is true, then maybe there's several different groups of solutions to the same equation, like mathematically, and maybe one of these solutions suggests an anti-universe. Okay. You know what I'm saying? I mean, this is, just the thing that people do. They just look at these equations, look at these solutions to, cosmological models, and they track down consequences. Say, well, this is true, then maybe this is true too. Maybe this is a consequence of it. That's all they're doing.
Yeah, talk to us about the process of this. Like, it starts with, building upon existing theories and trying to make sense of those. And then you sort of have to play out these new theories and write them down and do the math and publish a paper and have reviews on it, and other scientists say, well, this is where you're wrong.
Right.
Talk about the whole process of coming up with these ideas. And
well, like I said, this is probably based on, for example, what we're trying to do is to figure out this thing called string theory, which I have mixed feelings about, but it's basically a theory that would bring gravity and quantum mechanics together, because those two theories don't fit, and they're trying to make them fit together because they're both true to some degree, and we want to make them work together. And there are probably several different models of this idea. So what happens is people take one of these models, and when I say model, what I mean is basically a mathematical model. Okay, it's actually an equation on a sheet of paper.
Interesting.
And they take this and they try to solve, say, a particular equation. Turns out this particular equation that describes the evolution of the universe. I know it sounds strange, but yes, an equation could describe the evolution of the universe. Maybe this equation has more than one solution. Maybe one of them makes sense in a sort of a time increasing, moving forward model. But maybe there's another solution to it that's perfectly believable, that's perfectly legitimate in a mathematical sense, but suggests that the universe you can have another solution to the same equation is one when time runs in the negative direction. Yeah. And so they think, well, maybe that's another whole universe because we have a mathematical solution here that says it should be so. And it's easy to say, well, that's nonsense just because the math says it doesn't mean it's so. But over and over again within physics, oftentimes when the math says there should be a solution, we've looked and there's been a solution. It's been there. It doesn't always go like from observation to math. Sometimes the theory leads the way. Just pounding out math on a whiteboard, you get a solution, and then you look at nature and there it is. So, I don't know the details in this particular case, but I think that's what this, and then what you do is it's peer review is what you were talking about. You take this and you send it out to other scientists. They decide whether it's crap or not, whether it should be published or not, and if it makes it through, it gets published.
Yeah. Well, speaking of crazy headlines and a lot of math, this one says the universe may collapse in a big crunch sooner than we thought. Yeah. Which I read this and immediately, got anxious, started preparing for the end of the world. But
I'm going on vacation in July.
Yeah, I got to get that vacation. Good news is even these physicists say it won't happen for at least 65 million years. So
but that is really tight.
That's a blink of an eye in the
when I first saw this headline, I thought, because right now we're looking at like, universe coming to any sort of an end in trillions upon trillions upon trillions of years from now. Just like so far beyond the conceivable horizon. So I thought when I saw this, I thought, maybe, 30, 40, 50, 100 billion years. That would be pretty soon compared to
Right.
And then I looked at it and it said 65 million, which is, like when the dinosaurs died, which was a blink of an eye, cosmic time.
Yeah, so we're almost done here, is what you're saying.
Yeah, this movie's just about over when we just don't know it yet.
Yeah,
we're the ending credits.
It has this function. I read this article and thought about this in similar frames. Like, wow, okay, so maybe our whole universe has a different sort of time horizon on it, and maybe just an astrophysicist from Princeton doesn't really have the details right here, the one who leads this idea. But it functions in our world along with the other cataclysm end of the world narratives. Like in religious teachings, a lot of religions also have some sort of a future event that's going to bring about some kind of a change in the world, sometimes for better, sometimes for worse, whatever, but there's something on the horizon. And to the human experience, when someone suggests, and it could be sooner than you think, that does something in human beings, that is really powerful. And I can see not only why someone would write an article about it and have it as a headline. I can also see why people would be pursuing it. Right? There's just something in us that wants to put things into a time continuum and to keep double checking if it's soon enough. It's probably built into us, in the worlds that we live in, where we're not running from animals or feeling, like we're living in, a time period or a place in the world where animals are going to be the harm to us. But when a little kid is going to cross the road and you get to the road and someone says, you have to hold my hand and look this way and look that way and look this way again and look that way again, and then we'll decide if we're going to go. Like that toddler crossing the road narrative, boy, that just lingers. Just hangs all the way into someone's like, let's just double check those numbers on the collapsing of the universe and see if they're like how far down the road does that car have to be before it's safe for us to cross the road? There's just something very human about it. And you take all the cosmos and all the cosmology and all the stuff.
Yeah.
And it's I can totally get why we would do this. And
do you know what it makes me think of? It makes me think of like Kurzweil and these futurists who talk about like the coming singularity. Do you know what I'm talking about? It has to do with computers becoming self-aware. And
I have a copy of The Singularity is Near tome.
Yeah, right. But it's the same kind of thing. It's like, is this going to happen next week? When are the machines going to take over? And what's that going to look like? Self-aware may not be the right word, but at least more intelligent than us is at least in some way. And so, I read that stuff and I get the same sort of chill. It's like, whether it's true or not, I have no idea.
Yeah,
I have no clue whether this stuff is really going to happen or not. But when these smart people get up and start talking about it, it's like, oh. Okay.
Yeah, and I think that's right. And they're smart people and they're paying a lot of it, and they're smart in the sense that like they know this world really well.
Right.
They're also just human beings for whom this question is part of consciousness, right? Like, when is all this going to come to an end? Whether that's for you personally or some moment you're in or season of life, like we have a running timer in the human experience that wants to kind of make a calendar out of things. Like I think that the anthropologists and cultural sociologist people believe that one of the places where we mark the dawning of consciousness is when humanoids started keeping track of time and logging it. I think that's right. Right. I mean, I remember
marks on the sides of the cave walls,
and creating calendars and kind of measuring time. Like that's one of the things that comes along with the human experience, because sometimes, a lot of the science stuff can feel, well, I don't know if you feel this way because you're maybe in the world and you know it well, but to a casual observer, a lot of times it can feel very like, hey, your little human life here doesn't really have a lot of consequence. Like the things we know, the math, the science, the data, it's going to do its thing. And really your feeling about it, your whatever, not really something that anyone's taking into account here.
Yeah.
But
it's sort of a chilling thing.
Yeah. Okay, so let's just say a word or two about what they're getting at here, though, because it's also somewhat interesting that there's an expansion of the universe, right? That's a thing we've talked a lot about.
And right now, and remember in this conversation, it's actually speeding up. The expansion right now is getting faster and faster.
And then at some point, the belief is that it will stop speeding up. And their theory, if I understand it right, is once it stops speeding up, the slowdown could be incredibly fast, right?
Yes,
so all the Big Bang caused this huge expansion that's been going on for, how old do we think the universe is? What's
13.8 billion.
The
years,
universe.
13.8 billion, years, not days.
And the Earth is what's the current guess?
4.5.
4 billion.
4.5, yeah.
So boom, like billions of years this thing's been expanding. Once that changes, they're like, oh, it's not going to take billions of years,
right?
Because all that energy we don't know how to describe, so it's called dark. Is that fair?
Yeah, that's right. Dark energy.
Is that fair? Yeah, we don't have a name for it, so it seems hidden in the dark, which is also a curious term that scientists continue to use. Like it's such a strange little metaphor, right?
It is.
That's going to just, once that starts that move back in this collapse, so it goes from a bang to a crunch, is going to be way faster. It's almost like climbing a hill on a bicycle or on roller skates, and then you get to the top of that hill and you go down the other side an equal distance.
Yeah,
but way faster.
Yeah,
because gravity's pulling you down rather than sending you away. That's how I was imagining it, and that's, I don't know, that seems to make some sense to a guy like me who doesn't know much about any of this.
Well, this dark energy thing, it actually showed up, and he wasn't aware of it, but he had a term in his equations, Einstein did, that actually describes it perfectly. And it's supposed to be, and Einstein's equations is basically constant, this dark energy. Okay. It doesn't change in time. And it's a dark energy that's making the expansion speed up. Okay. That's causing it to go faster and faster and faster. This mysterious dark energy, whatever it happens to be. But what this paper is proposing is that dark energy, it's real, but it's also changing and decreasing. And once it drops below a certain critical value, it's going to not only will the expansion not speed up, but it'll actually reverse, because of the way it's decaying so quickly. This dark energy is decaying so quickly that once it's gone, it's going to be like that. Poof.
like pulling a rubber band and then letting it go. Just,
yeah.
All right. So not to send Dan into, nighttime shivers, but why are they confident that the expansion will continue, if not for 1 trillion years, as people have maybe previously thought, but why do they even think they know enough about where it is on the timeline to think, well, it's got at least 65
I don't know.
years.
I don't know what model they have of this that they're using. I don't know what that is. I mean, I'm familiar with the term itself, dark matter, and I'm familiar with where it shows up in the equations and so forth. But I'm not familiar with what evidence they have or why they think it's actually decreasing.
And are you familiar with this term quintessence? It says when the researchers just attempted to model this, Einstein's cosmological constant of dark energy, they concluded that dark energy is an entity called quintessence.
It's just
which
another
can
label.
Decay over time. Did they just make this up for this, or is this something that's
no? It's something I've heard every now and again, but that's an
Okay.
ancient term. It's an old term, fifth essence. They had basically they had water, fire, air, and earth. Right, those are the four elements,
okay.
and this was the fifth, with the quint, the fifth essence. And back in medieval times and before, it was thought that this is the element that ruled the cosmos above the moon. So basically, the cosmos was composed of quintessence once you got above this, what we'll call the sphere of the moon. And but that term has been passed down and used a lot.
Gotcha.
But at this point, I think that it's simply, as far as I can tell, and I may be wrong, is that it's a word for dark energy that changes in time. That is
not constant.
Yeah,
it changes. Yeah,
but it's not like an element that we've discovered that we know is real and we've done experiments and observations on.
Yeah, it's just a mathematical piece of an equation that makes it make sense.
It's a way of it's sort of a mathematical way of accounting for the facts, without any explanation beyond that at this point.
But I really like the notion. I mean, thanks for that explanation. That it's the fifth essence.
Yeah, it's the fifth element.
Feels better than fifth element. That feels better than dark matter.
Yeah, I like the term better too.
I mean, for all the functions that like white is pure and dark is unknown, like it just plays in our psychology in ways that I think has great social consequence that we're not always, as attuned to, and probably should be, about good and bad and light and dark and all this kind of stuff. But I think about the band called The Fifth Dimension. It's a great band. Maybe we should start a little band, the fifth essence or the fifth element. But that's kind of cool. That feels so much like that. Is it the same thing as dark matter? That when people say quintessence,
it's not identical to it, as far as I can tell.
Okay.
It's not identical to it. No.
Dark matter is still a grab bag of things.
Dark energy. Dark energy is still the term that is used to describe a very particular thing.
Quintessence, and that's pretty cool. That there's a fifth element of things,
right? That we can't access directly. Yeah,
we travel with Earth, Wind, and Fire, and the fifth dimension, and our little band, the fifth essence. That can be real.
Well, I want to make sure we get to this last story. This team is finding that younger exoplanets are better candidates when looking for other Earths. So we're searching for, other habitable planets.
That's right.
Tell us about this, Paul.
Well, what we're looking for is life in the universe outside of the Earth, and we're looking at other planets. We think planets are a good place to look, and there's a lot of them to look at. So what we want, basically, what are the requirements for life? Well, one of them is that, liquid water should exist. Another thing is that as far as we know, we should have a carbon cycle. That is, a planet should have carbon in the atmosphere to keep it warm, because we have some carbon in our atmosphere, this is a whole separate subject, of course. And having some of it there is necessary. We absolutely must. If we didn't have CO2 in our atmosphere, our climate would be basically that of Mars, and we couldn't live. So it's good to have CO2 in the atmosphere, but where does CO2 come from? Well, it doesn't come,
Republicans. I've heard it comes from Republicans, and if there were less of them. Is that not true? Is that not where?
Yes, that's right.
Okay, where does it come from?
I'm not going to contradict the host here.
Yeah, that's right.
Yeah. So it comes from volcanoes, basically. It comes from the planet outgassing, is actually the term for it, which comes from plate tectonics, right? We think that having plate tectonics, that is continental drift, the thing that's rearranged our continents over time, is necessary for life because it's this process that drives that's the same process that drives the production of CO2 in the atmosphere.
Didn't know that.
But where does that come from? What drives continental drift? What drives plate tectonics? Well, it turns out radioactivity in the Earth's core is what drives it.
Oh, really?
Yeah. It's a huge source of heat in the Earth. Decaying uranium, decaying thorium, potassium, elements like that down in the Earth's core produce an enormous amount of heat. And that's what drives plate tectonics. That's what allows volcanism to happen. That's what allows CO2 to be in the atmosphere. That's what allows us to have a livable atmosphere. So one thing that we think must happen is that you must have radioactivity in the core of the planet to have life. And
how can they determine that when they're looking at an exoplanet or another planet? How can they tell does it have a radioactive core? So you've got some plates shifting. Do they look to see if there's CO2, or do they have another way to know?
No, we can't. We can't see it whether it has CO2 or not. We can't get any details thus far on the atmospheres of these planets. But what we can know is that younger planets are more likely to have nice radioactive cores because it decays over time.
And Earth would be considered a younger planet, a little 4 billion year old little toddler of a planet.
Yeah. Okay. Which means that we should only look at certain kinds of stars because certain kinds of stars are necessarily younger than others, and their planets would be as old as they are, which makes them younger. So that helps us limit our target. Yeah.
I know this isn't exactly on the exoplanet thing, but this description of where heat comes from, where CO2 comes from, I'm certain, and people that I listen to seem very certain, that human activity on the Earth also produces CO2 and enough CO2 to tip the balance, a very sensitive balance, to make life more difficult for human beings to exist on the planet as it currently exists. So climate change, global warming. Granting that's, let's just say, okay, that's true. Now let's play with that a little bit. Are there any people who are saying, look, CO2 levels are going up, but it's the volcanoes? Like there's another thing explaining this. If it's, if it's like radioactive and that's, that got us to the perfect stasis of life. Is there any suggestion that, look, it's this thing that's happening is happening because, seepage or gassing at a different level than there has been in the past, or
maybe we need to plug some of the volcanoes, plug them up.
I guarantee you,
shut them down.
I guarantee you, some people have proposed that, but most of this volcanism I'm talking about has happened in the past. It's not what's happening now, because volcanism in the past was 1,000 times more prevalent than it is now. So,
and there's no current thought that something's been queuing back up, and there's been, it's been back on the, because if there was a time when there was a lot of volcanism and now not, so there's no evidence of that.
No. And we have seismographs all over the world. Every time there's even a volcano hiccups, we know it. So,
no. So it isn't coming from there.
No, it's coming from us, no doubt. No doubt.
We are the new volcanoes.
We are the new volcanoes, and we're adding. Yeah, we're adding to it. Now we're not doubling it or tripling it. It's not like that, but we're adding enough to it to where it makes a difference. It doesn't require a big change in the amount of CO2 to produce a large change in the temperature.
Do you think "We Are the Volcanoes" could become the album name of the Fifth Essence first release? That we are the volcanoes. Because I remember 4 or 5 years ago hearing a climatologist say, "Look, it's absolutely the case that the Earth's own changes over time have created different epochs,
absolutely
ice ages, and we have a pretty good way to measure that. So a reasonable argument could be," this climatologist said, that, hey, maybe we're in one of those periods of heating up like we've had before, that's been very hot and then been very cold. And this person said, but the thing is, we know that we're in a period where we should be cooling, that in the cycles, we're not in a place where the volcanic activity is causing this. We're in a cooling stage.
Right.
And so the fact that we're seeing an increase in CO2 in the period of time when geologically we should be seeing a decrease in it and less heating up, that shows that, not only is human activity adding something, but it's overcoming this period of cooling, which I thought more people should talk about that, because it's easy for people who don't buy human impact and climate change to say, but we had an ice. I mean, this is really, I had trouble 25 years ago kind of getting my head around this. Like, we had an ice age. I live in a place where all of our lakes are created by a gigantic glacier that ripped through here. Like, everything was frozen. And now it's not. So change happens, it's just geological climate adjustment and change. And is that not what's going on? That seems to a lot of people like a more plausible answer, frankly.
Right. But it seems to me that nobody is doubting, not even Republicans, are doubting that we are absolutely dumping CO2 into the atmosphere. Is anybody arguing that we're not doing that? Obviously we are doing that and have been doing it for 100 years.
I was going to check with Madison Cawthorn, Marjorie Taylor Greene.
CO2
actually doesn't exist.
Yeah. But you're probably generally right. Yeah.
We're doing this. It's obvious that we are in fact doing this. And not only that, but that we've never done it in human history before at this level. Never have we dumped so much CO2 into the atmosphere so quickly. Why is it so unbelievable that we're causing it?
Yeah,
I don't understand why that should be. Are they experts and they know that the amount of CO2 that we're putting into the atmosphere should not have this effect? They really, I don't know. I just don't get it.
I don't get it. And I don't get okay, what if it's not affecting the climate? It's still poisoning our planet in a million other ways. Like, why would we not care about poisoning our own air and water supply?
And not only that, but there's so many other ways that we can power ourselves, and so many jobs that we could have moving in that direction. It's just status quo. It's just,
okay, so I don't believe it, but I get it. Why people would say this. You fly in an airplane over this planet. You ride your bicycle from coast to coast. You take a car trip. You I don't know. You look at a drone footage. You look at a heat map. People are a teeny part of the landscape of this planet. It is huge and mostly empty. Mm-hmm. So. And I can see people saying, look, 77 billion people is a lot, but spread out over the globe, even though they're concentrated for sure in, a select number of pockets on the landmass, but even there it's really concentrated. We're just not big enough, right? I don't agree with this, but I can see this logic and how people go there, where they're like, there's just no way in the complexity of all of this that our cars or factories or farting cows with methane and beef production can produce enough of this. I think it's a scale question in some people's minds, and they think, and then there's a subset of these people, which might be even more than a subset. It might be the majority, which is human beings are under the divine control of God, and therefore God's not going to let that happen. There's that crowd, but I know there's others that are just like, seriously, so that's what I think drives a lot of this for people. Separate from I want to drive my vehicle that I have or whatever.
That's a logical fallacy known as proof by incredulity. It's like, I can't possibly imagine how that could be, therefore it's not.
Well, that's how I feel about light waves. Yeah, that's totally like there's no way. It's just a trick. You guys are just.
It's also a problem that people think linearly when this is a clearly nonlinear effect.
Yes. Well, okay. So say more about that concept again. It's the title it again. It's the
proof by incredulity.
Proof by incredulity. That is a great concept.
You know. And you see it in religious circles too, where it's like, you know, God must exist because I can't imagine how all this could be without God. You know what I'm saying? And I mean, I believe in God, but as a matter of logic, that's a logical fallacy to say that just because I can't understand it, I can't wrap my head around it, it can't be true.
All right, so I know we're going a little longer because you're a professor and school is out for the summer. Is it out?
Yeah.
Still got for the summer.
Still got finals happening and all that, but classes are over. I don't have to stand in front of people and talk about science anymore.
Great. So we have a couple minutes. Okay, so can we play with this proof by incredulity thing for a minute? I think that is functional. What goes on for a whole lot of people and how they think about the world is that, I have a concept of the world, how I think it is, and these things don't fit. So therefore I'm going to make this conclusion.
Right. Instead of accepting the world as it is, you stay with your.
But isn't that also what we've just gotten done describing as what scientists do? There's just a set of things that we don't know how to make any sense of them, but we just know they're true. And so we're going to continue to experiment and to test and to hypothesize and come up with an answer. What's the difference between proof by incredulity? I just can't imagine that couldn't be that way. And someone who says, there's something about this equation we have. Maybe there's another way to work this, because that just doesn't seem like it's the only way. Right. Somewhere there's an important difference there.
But, I think the difference
is that?
I think the difference is in the word maybe. I mean, maybe there's another thing here. Maybe there's something here worth investigating. Maybe we're, you know what I'm saying? I mean, I think that even the scientists who are proposing these things are aware of the speculative nature of what they're doing.
I see.
And what they can lean on is to say, look, in the history of science, 99 times out of 100, speculative ideas get thrown in the trash can, but 1 time out of 100, they don't. And so we're going to see if this is one of the 99 or one of the 1. And right. That's how I see it. And the perfect idea that there's a big maybe attached to that headline.
Yeah.
Whereas people who reject, you're not going to find that kind of subtlety of thought in people who flatly reject the idea that we are responsible for climate change. In general, you will not find that kind of openness.
Yeah. Mm-hmm. Well, and I was just saying that, I think it's true with climate change. I think just overall, the concept of proof by incredulity feels like that. I mean, I think that's just the operating system for a lot of us, right? For just a lot of life. There was some study done about like how depressed people or people that struggle with, like existential questions are actually the ones who are the realists. And the rest of us are just diverting ourselves with, hour and 9-minute long conversations about science. And, like we're just skipping along happily. And these people are like, look at this. You're going to die. Like you won't even. And you're like, I can't even imagine that I couldn't live. I can't even imagine I'm not alive. I've only ever imagined when I've been alive. Like so. I mean, I agree with you. I just think that proof by incredulity is the operating system for people. This has been very helpful because I think this is what any of us who go through a change in some thinking or belief are like, boy, I used to think this way. Now I think this way. It really is having to confront that, right? We believe what we believe because we can't imagine a world that's another way.
Right. Mm-hmm. And so we build up these mental models of what the world is like and operate accordingly. But every now and again, the world has a way of poking its finger in and saying, no, that's not actually correct.
Yeah, it seems like
and so the question is, do you harden your walls and hunker down, or do you sort of open the door a little bit and say, well, what is correct?
Mm-hmm. Yeah, it's a wall we've had to.
Hope to God I'm the second kind.
Yeah, we've had to break through those walls for generations. From the Earth is flat to now it's not. To germs exist. These were all things that people could not conceive. Like it was laughed out of the room when these ideas were brought forward.
Taking it back to the earlier conversation, the one you had yesterday about abortion, these constitutional absolutists who sort of look at the lines of the page on the Constitution and say, well, abortion's not in here.
Yeah, can't conceive of anything.
Right to privacy's not in here. So, and they just can't, they have this.
Yeah. And they are literally Supreme Court justices.
They are
you would think law school and maybe being a judge for a while would have corrected that, but instead it went the other way. I just think this notion that, look, we live by this proof by incredulity. I can't imagine a world otherwise. And I just don't have the energy to test all of it.
Well, that is true too. I mean,
that is really.
Things are up for grabs in a way now that they have not been historically. Because typically we were growing up in smaller towns with say a Christian city in Europe, with everything sort of more or less set. But now, what I mean is, it used to be that your identity was kind of set when you were born, and you sort of just fit into that for your whole life.
Right.
I don't want to oversimplify it, but now it's like we have all these choices. We have an unprecedented number of choices to make, and it just feels overwhelming. And it's like, damn it, I just want somebody to tell me what to do.
Yeah, I just don't want to have
to
think about how light waves work. Like, it's just exhausting to have to figure out the pattern and frequency of light waves. It just turn it on and make it more yellow, make it more orange, make it more red, make it more white. I don't want to have to figure it out.
But most people are happy with that, but Doug, you're not, and that's why you have a science section.
Science segment. Yeah, because I think this is fundamentally the question. And look, oftentimes religious people get a bad rap because they've earned it, right? Very, very often, the bad rap that we as religious people are accused of is just the paycheck from the work that we've done.
Well earned.
We earned it.
Yeah.
But religion also has a way to poke at people's bias toward things that just couldn't be another way, right? They ask another set of questions. Absolutely. and they work around. And for a lot of people, that's been very helpful to them. So they end up with a whole package of ideas that also came along with that, with the other things that just seemed like they couldn't be another way, right? There's no way we could not have a world in which fill in the blank. Until you're confronted with it, right. And that's really that's the human experience of maturity, right? That, like, death is the ultimate one. This is where the philosophical existentialists come kicking in, and they're like, the one thing you can't conceive of is that you're not alive. Like, right. So some people create a whole narrative about that will never happen.
Right. Fill in that big blank spot.
You're never going to not be alive, whether you're this American spiritualist or you have a life after death, religious heaven, hell narrative, or you have a consciousness narrative, or you have a ancestors narrative. Like, some way you're going to work around it. And, the people who are like, no, you're going to stop having consciousness, and therefore you're going to stop existing, and there's going to be no you that sort of carries on, and you can't possibly conceive that any more than you can conceive that you didn't previously exist. But you can't do that. So, let's go get a coffee and, maybe go to a movie tonight and sort of enjoy the sunshine. And they push on that kind of stuff. Right. And you can't just investigate everything. It just feels totally exhausting.
Exhausting.
I mean, you probably get this when you're teaching some kid about physics and you're like, so that chair you're sitting on, you do know it's not solid, right? It's just it's just particles vibrating, and you're going to sit on it and you're just going to live your life basically sitting on things and not questioning it every single time, if the laws of physics are going to hold.
Yeah, some people can get through life without wondering about that stuff. I can't do it, but some people, many very healthy-minded people can get through their lives without ever wondering about things like that.
Yeah, Barbara Ashley puts up a great little comment in here. And by the way, thanks Jim and Diane and all the comments, Barbara and Ruth, Peggy, all the comments. But Dan, can you throw up Barbara Ashley's? You can say the same thing with aging. She says, you go through life mostly not even noticing that you have a body until you reach a point when your body, through pain, starts talking to you, and you start to realize that it's the ending of you. And like that's a very real thing. So I think as we take on people who are like, seriously, can that possibly be how it goes? I'm sort of.
That's a great quote. I appreciate
that. I'm mentally waxing about valuing the proof by incredulity narrative, and I think people realize that that's a thing we all do.
Yeah, absolutely. Yeah. And oftentimes, like you say, just to get through the day.
Yeah, just
because it's too exhausting to do otherwise.
Yeah, like what sometimes a parent, it's important that they do a paternity test to see about the physical connection, biological connection between an adult and a child, to see if it's their child or not. But most of us don't have paternity tests. Someone could come to a kid and say, like, how do you know you're your dad's? How do you know that's your dad? Have you ever tested it?
Yeah.
No. I mean, who does that?
Right. You got to take a lot of things on faith. And I tell my students this, it's perfectly fine. I ask them the question, how do you know the earth goes around the sun? They had no evidence whatsoever. None. Zero. No arguments. No evidence of their senses. Nothing. It's because somebody they trusted told them it was true. Mm-hmm. And the truth is, that's perfectly fine.
That's perfectly fine.
But you can't treat everything like that.
That's it. See, boy, hour 17 minutes in.
Yeah, we got Snoopy has to pee. So we got
has to pee. Which is our code word for some of us, we have to stop this now. I think the act of maturity for any of us as human beings is getting to the point where we can differentiate the things that we're like, okay, this is just going to exist in the area because I'm just taking it. It's just, I just believe the people who tell me. And look, I'm not I'm not a Sherpa because I believe that, right? I'm not a sheep person, right? Because we all, and then you reach a point at some things where you're like, okay, hold on a minute. And all of us have that. We have our own arenas in which we operate. Right. Is the cosmos still expanding? Is it going to expand for a long period of time? We all assumed it's going to be billions or trillions of years. And someone's like, I'm going to actually pause on that one and take another look. And this is where your mentor of writing behind you, Phyllis Tickle, said something to me one time that I thought was really interesting. She said, anytime you're living in a time of significant change, of which we are globally now, and there's a lot of these periods of change, the question of authority is the foundational question. To whom do we listen, and on what topics? Yep. And we're in a crisis of authority. And if anything tells us about the American experience of where we are now, and I think a lot of the globe feels this way, is just who do we listen to as an authority? That is not as simple of a question as you might think. It is actually a very sophisticated, like, how do you form a web of belief that's going to operate in your life and your world? That's fundamentally what it is. Well, so Paul, glad to have you as a spider in our web of belief on this. Boy, this could be our longest live stream yet, Dan. Is that possible?
Oh no, I think we went a solid hour and 40 on some MMT stuff once.
Oh,
so we
man. Hey, you know what bend your mind is when you MMT is modern monetary theory, and don't use modern in too modern of a phrase. It's recent monetary theory, and part of its argument. Here we go. Part of its argument
open that can of worms.
Is we got to get back into that. That's our other Friday conversation is economics, but among its important notions is that the United States federal currency, like a lot of other currencies, is a fiat currency, meaning it only exists because the United States government makes it exist. It's not based on anything else.
Right.
And therefore, in modern monetary theory, the federal government doesn't take in any money. The federal government only produces money and removes money from the economy. So it's only a maker and a remover. It's never a recipient. So when you write your tax or you use, like I did, TurboTax, and it says you owe, $6,000 to the federal government, and then you process that with a direct deposit from your bank account to the federal government. It doesn't go into a federal bank account. It just leaves your bank account. It's just
added to this. It's just gone.
It's just reduced because the federal government doesn't take in money. Federal government isn't part of the cycle. State government, local governments, businesses, we all are. The federal government produces the currency.
And they take it back, but they don't actually hold it. They don't hold it. It's not like they've got a big building somewhere with all the money in it.
They remove it from the economy. It's a little nuance of language. They remove it from the economy.
Okay. And they also pump it into the economy.
And they pump it in. So when someone says, how are we going to pay for it? Well, the federal government pays for everything the way the federal government pays for anything. They produce the money. That's how they pay for it. The federal government does. So all new spending just is new money's created.
Okay.
When we tax, we take it out. Well, why do we tax? Modern monetary theory says, because you don't want too much money in the economy. That causes, here's the word, inflation.
Inflation, right.
So it puts too much money and then it devalues things and makes prices go up. So Dan's not literally going to go take care of Snoopy. So you're taking money out of the economy so you keep a right amount of money in the economy. So when we say we're going to send $300 million to Ukraine, where's the federal government get that money? They don't have a bank account with $300 million sitting in it like you or I would say, well, I only have so much money in my bank account. They just make it. And then they decide, are they going to take money out or not? And the difference between the amount of money that's gone into the economy, total from the foundation of the federal government treasury, that total amount, and the amount of money that's been taken out, the difference there is what we call the deficit.
Oh.
So the deficit is not a debt. The deficit is the difference between the amount of money that the federal government has put in and the amount of money the federal government has taken out.
Okay.
So if there was zero deficit, there wouldn't be any money, right? So there's a great book about this, or you can watch our YouTube videos, which are even better and much more entertaining. A woman named Stephanie Kelton called The Deficit Myth. And these are not people that are like coming up with like just theories. Modern monetary theory is not like, well, imagine if it was this way. It's a description of how things actually
how it actually is. Okay,
are.
So when on those odd years, those weird years when the government owes me money and I've overpaid my tax, they just write a piece of paper with a number on it, and it just so happens that my bank recognizes that as money.
Yeah,
that doesn't actually come out of an account somewhere.
No. It comes from the United States Treasury, right? And the United States Treasury does not have a bank account.
So my bank just sees that check and says, "Okay, we'll increase this number on your in your account by this same number," and then and then you can make that real by withdrawing it or by spending it.
Yes, they've put it into the economy by putting it into your bank account. And the federal government does this through the banking system. They say to banks, there's a system between the federal treasury and a consumer, and that system is the banking system. So they give rights to the bank to make money on their behalf.
You know, when I learn things like this, because I've never really thought, haven't really thought about this. This is not what you just told me is fascinating and not evident, not self-evident at all. It gives me the same feeling that they must have had back when Copernicus said, no, actually the Earth is moving under your feet.
It's exactly what we talk about. It's like the Copernican revolution.
It's like, whoa, whoa. It's like you're getting into and you're poking into my little concept world here that I live in.
Yeah, your proof of incredulity.
Yeah. Like moving the earth it's like you're pulling the earth out, the rug out from under me. You know, it's
it is, and it has so many implications about. First of all, it just explains how the economy works. Like you say to yourself, how does our economy grow?
That's exactly what I've always wondered. It's like what does it mean that we owe China so much money?
Yeah, and we don't owe
yeah.
So
We gotta say this.
We don't owe China any money. China has said, "Hey, we're willing to take some of the money that we have out of circulation for a period of time so that it doesn't overheat the system." So imagine there's a big pot of boiling water. It's starting to overflow, and you take a cup and you scoop out a little bit and set it aside so it doesn't overflow. Mm-hmm. So you take it out in bonds, we take it out in debt that's owed, and then you're going to put it back in. That's all it's doing. You don't owe someone any. The U.S. could just say, okay, all that money, let's just put it all back in the economy, pay off the deficit, put it all back in the economy, and all of a sudden there'd be so much money in the economy, our system can't deal with it because we're putting new money in all the time. So, because we're building roads and we're doing all these things. This is why Manchin says if we do this big infrastructure spending bill, all this money goes in, that's too much money. Is going to heat up the economy in the metaphor. It's going to raise the Kelvins, and it's going to overflow with too much money and cause inflation or current inflation. Some people are saying it's because too much government spending went in. This is a technical point, but it's actually because there's not enough money being spent because of supply chain issues. So in other words, it's scarcity, not abundance, that's causing this current inflation bit. So, I'm telling you, there's some videos you could watch here, ours or others, with a number of these economists.
One more question.
Yes. Yeah, all day long, Dan, all day long.
So when I read on Twitter these people complaining about canceling student debt and saying, who's going to pay for it? Nobody's going to pay for it.
Nobody's going to pay for anything.
Right. So all that means is that people are not having $600 a month sucked out of, reduced out of their accounts. That's all it means.
That's all it means. Now, because federally backed student loans are owned by the federal government, when you pay your student loan, what they're doing is just removing the money from your bank account and taking it out of the economy.
Okay.
When they give you a tax cut and they say you keep your money, we're saying we're not going to take that money out of the economy. So when Democrats say the government increase the deficit by this tax break to the wealthy, what they're saying is the government is not taking money out of the economy, so therefore the deficit went up, because the deficit is this number between how much is in the economy total and how much has ever been taken out. So tax breaks always increase the deficit unless other monies come out. So if you spend your money and then pay a federal sales tax, then it comes out some other way. But comes out doesn't mean it goes into. And this, I'm telling you, the number of people who we've been in these conversations with, and I talk to about this stuff, who are like, what do you mean the government just makes the money go away? Because they think about the closed loop system. Right.
They think of money being an actual thing that can't be created or destroyed.
And economists use this funky little language in 2008, the way they solved the then financial crisis, meaning that all these banks were collapsing, and banks were the apparatus that was moving money through the system. And so there wasn't going to be enough money. And all of a sudden people didn't know how to get money because the financial collapse. The answer to it is this phrase that is true, accurate, but people don't know what it means. And it's called quantitative easing. Maybe you've heard that phrase, we're going to solve this by quantitative easing. And when you break down the word, it's pretty simple. We're going to ease the amount of money that's in the economy. The quantity of money we're going to ease the pressure. In other words, make more. We're going to put more money into the economy as quantitative easing.
Okay.
So they just went into a computer and did a stroke and put in $100 billion into the economy and just changed the number and then said, there's enough money. So that's how the federal government, the U.S. or Canada's federal government, any government that has its own currency,
China,
does
whatever.
this isn't unique to the United States.
Right. I get it.
So it is such a mind-opening thing about the federal government and changes all these political arguments. So now you should have an argument about, should we be taking money out of the economy or should we leave money in the economy? That's
all
the
we're
question.
really asking. Yeah.
That's the question. And then whose money should we take out and whose money should we leave in?
That's
so
the question.
Fundamental question of, should we even have taxes? Which I thought, as a progressive person, that was an off limits question. Of course you should have taxes.
Of course taxes.
Our current president, when he was not the president, even said things like paying taxes is your patriotic duty. Like, no, it's not, because you're not paying for stuff. And by the way, as much as I hate war and want our military budget to be slashed, I'm not paying for it. You're not paying for it. You don't pay for anything at the federal government. The federal government pays for it. Now, you could make an argument because the federal government's putting $1 billion in, they want to take $1 billion out, and they're going to take it out. So if they didn't put that $1 billion in, but whether they put it into the military budget or school budgets or state budgets or sent it to counties as checks or sent it to each of us to spend on really cool Nito lights that have red light waves, any of that would be them still spending. So it just changes our relationships with this. Anyway, this is why we spend an hour and 40 minutes talking about these things.
I can see why.
It's just
modern monetary theory. I'm going to
MMT. We've got some great. We have a guy who's a professor at a university in Ohio, Fidel Kaboob, who's on, and he's the real MMT pro, and he's our Paul Wallace on the many of the other weeks that you're not on. We're like talking to an economist about like, okay. And we actually, Dan, you remember this like a year and a half ago when this all started? It was just like, okay, hang on a minute. Now what? Like just baby stepping until now, I'm an MMT.
It's like you can't pull the curtain back too quickly. You kind of got to do it. Yeah.
You got to go step by step and metaphor by metaphor. And the audio version of Stephanie Kelton's book is really pretty great. And we've run some of her presentations here on the podcast. And so it's called The Deficit Myth. And the first 5 chapters, which aren't all that long of chapters, and they're not economist lingo at all, is extremely helpful. Mm-hmm. And she actually worked in the Senate as a staffer. And so she answers the question, like, why do people not know this? She's like, I've been there. We've tried to tell people, and people in the federal government, some get it, some don't, but none of them tell you this. And she has all these clips about Barack Obama. In fact, this crowd really thinks Obama did a disservice to people understanding what happens at the federal level, because he would say stuff like, we can't afford it. We're broke. It's kitchen table issues. It's like, you sit down at your kitchen table and you decide how much money you can spend. And if you don't have the money, you don't buy it.
I've never really believed that. I never knew why I didn't believe it, but I always felt like, but isn't it different when you're the federal government than when it's me making paychecks every month, with this clearly limited resource? I've always thought that was
it's and then it raises the whole question of
raises the question of when we're going to stop this podcast.
Are we ever going to stop? Why can you imagine anybody still listening? Why is there currency at all? And the big question, the answer to that question for most people is because it made it easier to move from a barter system to a currency system. It was too complicated for me to trade my shoes for your grain, and I don't need as much.
It just made it easier. It's a go-between.
And they're like, nope, that never happened once. That's never how it's developed. That's not why we have currency. So why do we have currencies at all? Why do
currency,
government?
You mean cash? You mean
why did the federal government? Why does any government create a currency? What's the function of a currency in our society? Why not just barter or something? It's not because of ease.
Is it
An
control?
answer on the next edition of
No.
Hangover. It's
Control,
to motivate. It's to motivate behavior.
It's to control.
Mm-hmm.
Control, or yes, or motivate. Influence, control. Get people to do certain things as opposed to other things.
Yeah,
that's why. So people that want, and cryptocurrency,
carrot stick thing,
is a movement toward having a currency driver that doesn't have the intention that any federal government's currency has behind it. It's one of the big things they were pushing for. I think crypto's a scam, but it's more like,
you want to go cards. Another hour and a half. Let's talk crypto.
Yeah, give me going on cryptocurrency. So anyway, it just starts answering like any good realization. It doesn't always teach you something new. It resolves a conflict that you had that you were just comfortable living with long enough. And you're like, holy, that's what that is. Well, that explains it.
Yeah.
Huh.
Yep. Yeah.
Like
it draws all kinds
great.
of,
that's great discovery.
Yeah. That is happens in science. Crypto is a scam.
No, I'm with you. For lots of reasons that which we're going to do a whole thing on cryptocurrency. Dan, should we do that next Friday on the economy on our economy podcast? Let's do it.
Love it.
Let's book it now. We'll talk. Republicans said deficits don't matter when asking for tax cuts. Yeah. Okay. So I could go on and on about I disagree with the Republicans 1,000 times over on nearly all things, especially economics. But they have a consistent thought about this because their idea is we won't take the money out through federal income tax. We will take the money out through user tax. That's their argument. They're wrong. It's bad. It's redistributed economy, all this, but it makes sense. The most devastating arguments are the ones that actually have a consistency to them, but are wrong, as opposed to the ones that really don't make any sense. So Republicans' arguments are more dangerous because they have a consistency logic to them, and they're fundamentally misguided.
But the fundamental thing that lies beneath them all, that draws them all together, is mistaken. But they have the appearance of strength because they're consistent between each other.
Yeah, because the argument works. It's just, no, that's not what people are going to do, and that's not what we want people to do, and it didn't actually turn out. It could have turned out that way. So it didn't like not make sense and could have never worked. It could have worked, but we know that by human behavior, it's not going to work because wealthy people are not actually going to spend all their money because they have too much to spend.
Right. They can't do it.
And everywhere they spend it, they also don't get taxed on it. So it never comes out. So it pools the money. It's like there's too much water in your backyard isn't actually true. There's too much water in certain places in your backyard. If you let the water go down deeper, if you let it be over on this other side of this tree, if you spread it all out, it's the pooling that's the problem. Our problem in our economy, when we talk about an unfair economic system, is it's pooling up. Some places are super dry, some places are flooded, and that's what's happening with our money. So the wealthy have too much, and the not wealthy don't have enough, and that creates an imbalance.
There's a small number of very deep puddles, and the rest of it's dry.
Yeah. Anyway.
Yep.
Well, that was fun.
We're almost at an hour. We're almost at an hour 40 minutes. I mean, we could set a record. We could set a record here if we were so inclined.
Dang.
But you're regretting that. Take that mute button off now, aren't you? Cats. Remember that an hour and a half ago when I couldn't get my mute button to work?
Whoops. Well, sorry, Doug. Sounds like you're muted again.
That's right. About MMT. There's lots of things on our YouTube channel. And if you're watching this anywhere other than on YouTube, come June, all of this is going to be at YouTube only, not on Facebook and the other places. So we'd love you to go right now over to YouTube, subscribe to our channel, and just start watching playlists over and over. We need to get to a certain number of watched hours in order for some magical algorithm things to be opened up to us. And we're very close and we need some help. So we'd like it to happen by June for a whole lot of reasons. So if you could do that, go to our YouTube channel, Vote Common Good, start a playlist, just turn your computer on and let it run with the, with the volume turned down. Just run hours and hours of what come a good playlist. All right. Is that enough? Should we talk about anything else?
I think I'm done.
I got to get out of here.
I'm exhausted. I just want to go home, and I am home.
Take a nap.
That's horrible.
Woo,
all right.
Look at that.
Go to Red.
All right. Bye, everybody.
Bye.